All right, this last section in chapter 5, we introduced integrals, which is now going the opposite direction of derivatives. It's finding the areas under curves. Up until now, we've had a function, f of x, in a certain closed interval, bounded by, there are 4 bounds we have to think about. Bounded above, bounded below, the left bound, and the right bound. Because we're only looking for the area under the curve in those domains. So it pretty much parametricizes our function. The left bound is A, the right bound is B. What's above is our function, and what's below is the x-axis. So far, so good. I mean, that's what we've been doing. Well, if you notice, our lines, bless you, our lines that we add the areas go from the function down to the x-axis. So it stops there. And we use on the x-axis, our bound, left and right, is what's our domain that we're looking at. So the area goes from our bounds A to B. And if you look at it, and once we figure out the antiderivative, the opposite of it, then we can find the area under the curve. Now, in algebra, when we talked about slope, how do you find the distance between 2 numbers? How do you find the distance between 2 numbers? For example, what is delta x? How do you find it? What's the formula for it? Right. So that's how you find the distance between any 2 objects, any 2 numbers. So that's the formula we're looking at. That's horizontally. It works vertically also. So how high is this? In this, we go larger minus the smaller. So what would delta y be? What's the higher? It's the f of x minus what's the low end? It's the x-axis. So that's how we parametricize and find that rectangle. So our formula we can look at it this way. Does the x-axis have a formula? What's the formula for the x-axis with respect to f? So it's not f0, it's f of x. It is 0. The x-axis equals 0. because this is the y-axis, it equals 0. So at y equals 0 is the x-axis. So y equals 0 equals the x-axis. So we've been doing this all along. Because in this section, we're now going to look at the area between two separate functions. That's the goal of this chapter, of this section. So we have to get to that far first. So this is our goal for this section, which is where Calculus 2 begins. Theorem 7. Substitution in definite integrals. So what does substitution mean? What would you use that for? Yeah, it's a change of, first you could change the values, not the values, but to change the function itself. We did it last chapter. Remember, we had f of g of x times g prime of x. Remember we did that? And so what we did is we let u equal the inside function, and then we found du as g prime with respect to x. So we've done it already. Now let's define it, because we're going to be using this a lot in this chapter, in this section. So here's the theorem. As we said over here, if g prime of x is a continuous function on the closed interval AB, and f of x is a continuous OUS function on the range, of our g of x function, so if that's true, then we know from last section, this we did last section, if we use substitution, this is the important thing. Not only do we change what the function looks like, because now what this becomes is f of u du. Because if g equals u, then g prime is u prime, du. All right, that's the first thing. So whenever you do that kind of transformation, we have two methods we can solve here. If you use substitution, you can do the integration, and then at the very end, come back and plug in a and b. Or you can stay in the substitution. We can stay in u if we change the bounds of integration accordingly. Since we're changing Instead of g of x, we now use u. We now have to define what is u at A, what is u at B. So that's what it's saying there. And we could do either of these. It'll give us the same answer. We can do the substitution method and then plug in our values at the end, or we can use the substitution and change everything right off the bat, and it makes it much easier. It will become shorter, actually. Example 1. Evaluate this. From -1 to 1, we have 3x squared square root of x cubed plus 1 dx. So let's do both of those methods. Using substitution and now say changing substitution. So this is our first method. So we have the integral of -1 to 1 of 3x squared x cubed plus 1 dx. So what's going to be our substitution here? Remember, u equals g of x. G of x is the interior function. So what is our u? X cubed plus 1. All right. So because we're using u, we also have to find du. What is du? Three x squared dx. All right. So wherever we see x cubed plus 1, we put a u. Now, do we have 3x squared dx inside the equation? Yeah, here's 3x squared, and here's dx. If we put them together, we have du. No, that's just setting it up.
I know, but so the 3x squared doesn't exist. You did not put the 3x squared.
Well, no, because if this is, remember, we have to go backwards. And earlier in this course, we learned the chain rule. The chain rule, you take the derivative of the outside, then you take the derivative of the inside. The derivative of the inside is 3x squared dx. So I have that. So now instead of this, 3x squared is du. Both of these I can put together as being du. So now I have this. Which means what? I can take the integral of this one now, power 1/2 du. But I'm going to stay with you. I'm not going to change away from u. I'm going to keep u in there. I'm not going to go back and put it in place of x. Because I'm doing that, I have to change the bounds of integration. So since I changed x to u, what is u at -1? When x equals -1, we got -1 cubed is -1 plus 1 equals 0. So my lower bound at -1 inside here, it becomes 0. My upper bound, my u value when x is equal to 1, I plug that in place of x. So 1 plus 1 equals 2. So now that becomes 2. I have just changed my bounds to reflect the variable u. So let's integrate this one. What is the integral of u to the power 1/2? U to the power 1/2 plus 1. And whatever I have in exponents, I put on the bottom. It's going from 0 to 2. So it's 2 over 2. So it's u to the power 3/2 over 3/2 from 0 to 2. Flip the bottom, so we have 2 over 3 u to the power 3/2. Again, all algebra. So this one becomes 2/3 times 2 to the power 3 over 2 minus 2/3 0 to the power 3/2. I don't need it, see. Anything times 0 is 0. So in this one we have 2/3. What this one becomes is 2 cubed is 8. So it's 8 to the power 1/2, which is a square root of 8, which is 2 square root of 2. Again, let me. 8 is made up of 2 times 2 times 2. Since we have 2 of a kind, it comes out in front. So that becomes 2 radical 3. 2 times 2 is 4, radical 3 over 3, and there's the area. There's the area under the curve. So I left it as u. Okay, let's go do the second method, which we will transform back to x. In other words, we'll keep the same bounds of integration. We'll use the same functions. So we're going to go from -1 to 1. We have 3x squared x cubed plus 1 dx. Let's rewrite this function. So the integral, we have to work this one backwards. Here we have the inner equation, and the derivative of that one is 3x squared dx. So that works. So what we have to do here is take our equation, x cubed plus 1, add 1 to our exponent, and divide by 1. And that's going from the same bounds from -1 to 1. So this becomes x cubed plus 1 to the power 3/2 over 3/2. Now, you're going to ask, what happened to the 3x squared? Well, That's the derivative of the inside. If I only had x squared on the outside, how would I fix that? Because the derivative of the inside is what? The derivative of is 3x squared. I need a 3. Since I don't have a 3, I would put a 3 there. And then I have to put a 1/3 out in front. If you're missing a number, you can put it inside the equation, but you have to do the opposite of it outside. But since it's already there, all I got to do is take this equation. The 3x squared, this times this and this, that's the derivative of the inside. It's the reverse of using the chain rule. The chain rule says take the derivative of the outside times the derivative of the inside. The derivative of the inside is 3x squared. That's what I'm saying is this is our y prime. This is y, and this is y prime. So now I take it with respect to 1. Well, I flip this one, so I get 2 over 3 x cubed plus 1 to the power 3 halves from -1 to 1. 2 over 3, 1 cubed plus 1 to the 3 halves minus 2 over 3, -1 to the power 3 plus 1. Which is 2/3. 1 cubed is 1, 1 plus 1 is 2. -1 cubed is -1 plus 1 is 0. So again, 2 to the power 3 halves is the same thing as 2 to the power 3 to the power 1/2. So it's 8 to the power 1/2, which is the same thing as square root of 8, which is 2 square root of 2. Which is equal to 4 over 3 square root of 2, which is the same thing we got last time. Which method was easier? The substitution method is a lot easier. Most of the time, not always. A lot of times in trigonometry, it's a lot easier to use this type. So you have to know how to do both of them. Let's look at another example. Let's use the method of transforming the limits of integration. That's using the substitution method and changing the exponent or the bounds a and b. So we're going from our closed interval is pi over 4 to pi over 2 of cotangent theta cosecant squared theta d theta. Now, looking at both of these equations here, is one a derivative of the other? If so, which one's which? Because we have F and we have G. How are they related? Because the derivative of cotangent is cosecant squared, or negative cosecant squared. Again, that's on your cheat sheets. So what do we have here? Do we have everything we need? We have cotangent. We have cosecant squared. What are we missing? We're missing a negative. So we can put a negative there, and we have to put a negative out in front. So the answer is going to be negative. We have u du. Now, since we changed to substitution method, we have to transform these bounds with respect to this equation. So, we'll on the top one, u at pi over 2. What is the cotangent of pi over 2? Cotangent is what? It's 1 over tangent. So tangent sine over cosine. So cotangent is cosine over sine. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So that's 0. So instead of pi over 2, I now go to 0. And then the lower bound at pi over 4, cotangent of pi over 4 is cosine pi over 4 over sine pi over 4, which is square root of 2 over 2 over square root of 2 over 2, which is 1. So all we have to do is take the integral of this function there. So what's the integral of the negative from in front? What's the integral of u? No. The integral of u, it's u to the power 1. So it's u 1 plus 1 over 1 plus 1. We're not substituting back. We're leaving it as u. So it becomes u squared over 2 from 1 to 0. So the negative out in front, we have 0 squared over 2 minus 1 squared over 2 equals negative 0 minus 1/2. So we got negative of a negative 1/2, which equals 1/2. There's your area. Nerds, in this method, we're not going back to cotangent. Once we make the substitution, we stay that way. Here's another example. Part B of this question. At negative pi over 4 to pi over 4 of tangent x dx. Remember, we have to put it so we can figure out what is u and what is du. For tangent, what is tangent made up of? Sine over cosine. Usually, whenever you have a rational expression, a fraction, you in trigonometry, you set the denominator as your u. It'll be apparent in a second. So if the denominator is cosine, what's the derivative? Negative sine. Do we have negative sine? In here? You won't find it in your sheet. It's on the board. It's all right here. Is there a negative sign anywhere here? We need negative sign. Is there a negative sign there? Do you see a negative? No. So since it's supposed to be, we have to put it there. Because we have to put it there, we have to cancel it out. It's not a tough question. It's not a trick question. Do you see it? There's no negative sign there. But we need it to satisfy our equation. So what do we have? We have this top part is this is du dx, du over u. What is the integral of du over u? Look at your cheat sheet. What is the integral of du over u?
It's LNU plus C.
No. Well, that's if it's indefinite. We have a definite integral. We have bounds. So the integral of du over u is ln absolute value of u. But what are our bounds? So we have to change it from negative pi over 4 and pi over 4 with respect to u now. So when x is pi over 4, we got cosine of pi over 4. What is cosine of pi over 4? Square root of 2 over 2. What is u when theta is negative pi over 4? Are you sure? Is it positive or negative? Why? Let's look at this. Cosine. This is pi over 4. This is negative pi over 4. Which axis does cosine deal with? The x-axis. It's the same value, square root of 2 over 2. Because cosine is an even function. So we're going from square root of 2 over 2 to square root of 2 over 2. If the bounds are the same, what's our area? And we knew that was going to happen. Because remember, Whenever you do integration, if you have an area of 0, what does that tell you? If you have an area of 0 on a certain bound, because if you think about it, this is negative pi over 4, and this is positive pi over 4. The function is tangent. Function of tangent, these are the vertical asymptotes. So the area on this side is going to be negative, this side is going to be positive. So this tells us that these will cancel each other out. Well, once they're both same values, but different signs. So what we should have done, but that's not what it asked us to, it just told us to do this. What we should have done, instead of going from negative pi over 4 to pi over 4, we should have gone from negative pi over 4 to 0, and then from 0 to pi over 4, and take the absolute value of those. Whenever you have a 0 as an area, that always look for the x-intercepts first. Take your function, find the x-intercept, because now you have this interval and you have this interval to worry about. But the question didn't ask us to do that. It just said, use this in this method. Which leads us to this. What are symmetric functions? When I say symmetric functions, what do I mean? What does symmetric mean? Again, guys, as I'm saying, these are basic terms. These are the terms you should have learned in algebra. What is symmetric? If something's symmetric, what does it look like? What's that?
Like,
Mirror image. It's a reflection of itself. For example, x squared. The graph is a parabola. It's symmetric about the y-axis. When x is 1, y is 1. When x is negative 1, y is 1. Symmetric about the y-axis. Let's see what happens. When x is 2, what's y? When x is 2, what's y? Y is 4, because x squared. When x is negative 2, what's y? It's also 4. So symmetric about the y-axis means if I take x and y, and I just change the sign of x and get the same value y, then it's symmetric about the y-axis. These are what we call even functions. Even functions only have even exponents and or a constant value. For example, a constant function would be y equals 2. It looks like this. Again, when x is 3, y is 2. When x is -3, y is 2. So it's symmetric about the y-axis. So even functions are symmetric about the y-axis. Even functions have only even exponents, and they can have constant numbers. Symmetric about the origin. What this one does, if I have a point, then there's a mirror image on the exact other side. Y equals x cubed is a perfect example. When x is 1, y is 1. When x is -1, y is -1. When x is 2, y is 8. When x is -2, y is -8. So a function, an equation is symmetric about the origin is called an odd function. They only have odd exponents. Nothing else. Now, what does this have to do with areas? What does this have to do with areas? Even versus odd functions. If we're talking about symmetry, A and B have to be related. So basically what that has to be is, if this is B, this one has to be -B. Has to be the same distance away from the origin. This distance has to be the same as that. So the integral of an even function from A to B is the same as 2 times sorry. So if the function is even, if we know the function is even, instead of going from both ends, from both bounds, we can just go halfway through and double it. If it's an odd function, if it's an odd function, we know the area is going to give us 0. So what we have to do there is we have to change the bounds of integration and take the absolute value of both of those values to find the area. Okay, so what does all that stuff mean? Let's look at an example. That has to do a theorem for it. Here's a theorem for it. Theorem 8. Let f of x be a continuous function that is symmetric on the closed interval negative a to a. So again, it's even distance from the origin of both sides. We have two things. If our function is even, then our integral from negative a to a of our function is equal to 2 times half of that integral. That's if it's an even function. How do we know if it's an even function? Yes, an even function has only what kind of exponents? Only even. Can it have constant numbers? Yes. Even functions can have even exponents and constants, or either or. If f of x is an odd function, then our integral from negative a to a of our function is equal to negative a to 0 plus 0 to a. In other words, if it's odd, we know it's going to be odd if this occurs. If you start off and you have a function, you take the integral and it comes to 0, then we know it's an odd function and we have to split it up.
So with the odd function, the A and B is all equal.
Well, yeah, this would go from negative a to a. It has to be the same half to both sides. Because again, it has to be symmetric. So, and that's why when you do transformations, it gets a little more difficult. But right now, we're just taking from the origin itself. It's got to be the same on both sides, which is why one of the rules of integration is whenever you have a function, always first look for the x-intercepts. From negative 2 to 2, x to the 4th minus 4x squared plus 6. So what kind of function is that? It's an even function. So since we know it's an even function and the bounds are equal same sides, we can do the same equation by changing the bounds. Instead of going from negative 2 to 2, we go from 0 to 2. So that's going to give us, what's the integral of x to the 4th? X5 over 5. The integral of x squared is x3 over 3. And the integral of 6 is 6x. Okay, we should get to, we have to be now at a point, we know the derivatives are always take one from the exponent. When we do integrals, we have to add one and divide by that same number. Since the bottom number is 0, all of these are zeros, we have to worry about it. So all we have to do is worry about the top. Two to the fifth is 32 over 5. 2 to the third is 8 over 3 plus 12. The common denominator is going to be 15. So we multiply this one by 3 over 3, which is 96. This one by 5. 20 times 8 is 160 over 15 plus 12, 5 over, or 15 over 15. Is 180. Do all the math. There's our answer. Again, it's all algebra. This is adding, subtracting. So those are the shortcuts, and we get different ways to do it. Now we're going to look at areas between curves. Here we're going to have two separate functions on a closed interval. So if I want to know the area, here's my f of x, and this is my g of x. This one, since it's above, this is my upper bound. This is my lower bound. And we're doing it the same way. We have to partition the distance, those intervals for our areas. The area is still the same, is base times height. The height, what is the height? We know the base is delta x. That's easy. We've done that all the time. So the base is delta x. The problem is, what is the formula for our height? Remember earlier we talked about, if we just had this, our height is our function minus the x-axis, which is 0. Now we have two of them, so our height is whatever's on top minus whatever's on the bottom. Our height is f of x minus g of x. The upper one minus the lower one. So we have to add up all of those little intervals for each of these a's. Each one of these areas. So that's going to be the summation of f of ck minus G of CK times delta XK. And then to find the area, what do we have to do? To find the area, we have to take the limit as each of our partitions go to 0. F of CK minus G of CK delta XK. Remember what this was called? The Riemann sum. We use that to find the integral. So what this equals is the area from A to B of f of x minus g of x d of x. So this is the formula we'll be using whenever we have multiple curves. And here's our definition. Besides, I think I gave you the packet. You don't have to write all this stuff down because it's in the packet I gave you. So again, that's what I'm trying to tell you. Do not waste your time copying this stuff down because you're not listening to what I'm saying. You're just writing what I'm. So listen to what I'm saying. If f of x and g of x are continuous functions, with f of x being greater than or equal to g of x, everywhere on the closed interval AB, everywhere on there. Because if they cross, then we have to have multiple integrals. But we're not saying that f of x is bigger than g of x. It can also be on the same side. Here's f of x, here's g of x. The area is between these. It's going to be the same thing. So if that, then the area of the region the curves y equals f of x, y1, and y2, g of x, from A to B on the closed interval AB, of the integral of f minus g from A to B is written like this. The integral from A to B, f of x minus g of x dx. There's the definition of it. And it's important because it said that f of x has to be bigger than or equal to g of x. All right, so let's look at an example here. Find the area bounded above by the curve y equals 2e to the power negative x plus x. That's the first condition. Below by the curve y equals EX over 2. On the left by x equals 0. And on the right by x equals 1. So what this graph looks like, starts at 0, and it goes to 1. So this is f of x, and this is g of x. It's bounded above by f of x, below by g of x, from 0 to 1. We want this area right here. We want the area. So we have to put it up. So we have from 0 to 1, we have f of x minus g of x, which is from 0 to 1, 2 e to the power negative x plus x minus e to the x over 2 dx. Since all of these are add and subtraction, the sum and difference rules of integration, we can just do each one separately. What's the integral of e to the power negative x? The first one is going to be negative 2 e to the power negative x. That's the integral of it. So the integral of e to the power negative x is negative e to the power negative x. Yeah, that's what you'll see in your cheat sheet is EU du. The integral is the same as the derivative. Now the integral of x is x squared over 2. Whatever you put up here, you have to put on the bottom. Minus the integral of x squared, so it's 1/2 is a constant. So the integral of e to the x is e to the x. Which gives us 2 e to the power negative 1 plus 1 squared over 2 minus e to the 1 over 2 minus negative 2 e to the 0 plus 0 squared over 2 minus e to the 0 over 2. That is 0. This becomes 1. That becomes 1. So our solution for this one is negative 2 e to the power negative 1 plus 1/2 minus e over 2. Distribute that. So it goes plus 2 minus 0 plus 1/2. Because that is 0 becomes 1. So we got negative 2e over e, that's this one. 1/2 plus 1/2 is 1, plus 2 is 3, minus e over 2. There's your answer. Example 5. The area bounded by y equals 2 minus x squared and the line y equals negative x. It doesn't give us any bounds of integration. So what do we do? Find where they intersect. Find where they cross. Set the two equations equal to each other and see where they equal. Those will be your bounds of integration. Why? Because then you know you'll have one above the other. That's what you need. So you have 2 minus x squared equals negative x. Since it's an exponent of squared, we move these to the other side. So we have 0 equals x squared minus x minus 2. The quadratic equation, so we can try to factor it. Second sign's a minus, tells us the signs are opposites, and the bigger number has a negative. What times what is 2? When you subtract them, you get 1. 2 and 1. So set that equal to 0. We get x equals negative 1 and x equals 2. This is A and this is B. So we have our integration going from negative 1 to 2. Now, what we have to do here, figure out which one's f and which one's g. If we graphed those two functions, the line y equals x goes through the origin and looks like this. This is y equals negative x. This one is a parabola that just shifts up, opens down 2 spaces. So this is f and this is g. And it crossed that negative 1 and 2. So our function is 2 minus x squared minus negative x dx. Because we have f of x minus g of x. So we have 2 minus x squared plus x. I can rearrange those so it's decreasing order. So from -1 to 2, we have 2 plus x minus x squared. 2 plus x minus x squared. Integrate those. Integral of 2 is 2x. Integral of x to the power 1 is x squared over 2. Minus. Integral of x squared is x3 over 3. Do they make sense? Everybody follow those so far? Are you sure? Because this is very important. If you can't do this just now, then you have a lot of writing. All we're doing is whatever the top is, add 1 and put it on the bottom. So x squared becomes x cubed over 3. X to the first, x squared over 2. So I do the top number first. 2 squared over 2. 2 cubed over 3. Minus 2 times -1. -1 squared over 2. -1 cubed over 3. I plug in this one, then I plug in minus that one. 4 plus 2 squared is 4 over 2. 8 over 3 minus -2. That becomes positive. -1 cubed is negative, makes it a positive 1/3. So we get 4 plus 2 minus 8/3. Get rid of the parentheses, so we have 6 minus 8/3. Distribute. So it's plus 2 minus 1/2 minus 1/3. So we have 6 minus 8/3 minus 1/3 is minus 9/3. Plus 2 minus 1/2. 9 over 3 is 3. 6 minus 3 is 3. Plus 2 is 5. Minus 1/2. So it's 10 over 2 minus 1/2 is 9 over 2. Again, the procedure is all the same. Yeah, it's just algebra. These parts here, I shouldn't even waste my time. You guys should be able to do this yourselves. It's just getting that far the important one. Example 6. Find the area in the first quadrant in Q1 bounded above by y equals radical x and below by y equals x minus 2. We're given above, so this is the f of x, this is the g of x, which is above and below. We have to find the points of integration, a and b. So we set the two functions equal to each other. Solve for x. Square both sides. We have x equals x squared minus 4x plus 4. You have to FOIL. So that's where that comes from. Now solve for x. Subtract x from both sides. 0, x squared minus 5x plus 4. X and x. the second sign's a plus, so they're both the same signs. They're both the first sign, they're both minus. What times what equals 4? When you add them, you get 5. 4 and 1. So x equals 4 and x equals 1. Those are my bounds of integration. But now if we graph these two, the first one is the square root of x. The second one is a linear equation. Looks like this. This is g of x. I'm looking for this area. So that's why this is not a good value. Because all we know at that point is, do they cross that point? No. So we know that we have, where we're going from 0 to 4. We actually have two parts that we're going to look at. We have to find this area here, and we have to find this area here. So how do you find this first area? So area 1 is the integral. What's that function? X to the power 1/2. It's from 0. What is that intersection there? This equation is, so if we set x minus 2 equals 0, that's at 2. So we're going from 0 to 2 for this first area. So we get, add 1, we get x to the power 3/2 over 3/2, which is 2/3, x to the 3/2 from 0 to 2. So 2/3, 2 to the power 3/2 minus 0. So 3, so 8, the square root of 8 is 2 radical 2. So this area is 4 radical 2 over 3. That's the first one. Now for the second one, for the second area, now we have to go f minus g from 2 to 4. We have the upper bound minus lower bound. So it's going to be square root of, from square root of x minus 2 from 2 to 4. So we gotta hurry up because we're running out of time. From 2 to 4, and the area is square root of x minus x plus 2. So square root of x is x to the power 1/2 minus x plus 2, which becomes x to the 3/2 over 3/2 minus x2 over 2 plus 2x. So we have 2 over 3, 4 to the power 3/2. 4 squared over 2. 2 times 4. Minus 2. 2 to the power 3/2 over 3. Minus 2 squared over 2. Plus 2 times 2. Four square root of 4 is 2. 2 cubed is 8. 4 squared 16 over 2 plus 8. 2 cubed, that one's going to be 2 square root of 2. We've done that one 3 times already. 2 squared is 4 over 2. So 16 over 3 minus 16 over 2, which is 8, plus 8. 4 radical 2 over 3. 4 over 2 is 2, so negative 2 plus 4 is positive 2. Those cancel. So we have 16 over 3 minus 4 radical 2 over 3 plus 2. So we have 16 minus 4 radical 2 over 3 plus 6, which makes it 22 over 3. This makes it 6 over 3. So that makes it 22 over 3. So that's at area. And add the two together and you get your answer. Then you just add area 1 plus area 2. You'll get 10 over 3. Now the last part. I have to meet next time. We can take the bounds of integration with respect to the y-axis instead of the x-axis. You all have another class right now?
Huh?
You have a class?
Oh, yes, we have I have another class at 11.
Okay, when's your next class? Oh, okay, so we can finish up this last topic then.
Yeah.
Okay, let's finish this then. So now, instead of taking the integrals with respect to the x-axis, we're not going to take it horizontally. This is f of x. This is g of x. Right now, we're doing it this way. This is with respect to the x-axis. We could take it with respect to the y-axis. It's the same thing we did earlier with the substitution method, but now we have to change the bounds of integration. Instead of f of x being the highest one, f of x will be the furthest to the right. Instead of g of x being the lower one, it's going to be the furthest to the left. This is where we used to do it. Now we can find the area with respect to f of y minus g of y dy. So you see, we have to change the bounds and everything else that goes with it. So let's look at this one. Example 7. This is what we had in example 6, we had this. So this is our f of x, and this is our g of x. And remember, in that example, this is what we did in the last example we just did. This is what it looked like. We did it up and down. Now we're going to do it with respect to the y-axis. So with respect to the x-axis, we had the integral from 0 to 2 f of x minus g of x. Then we added the integral from 2 to 4 f of x minus g of x. That's what we just did. Now, this one went from 0 to 2, then 2 to 4. If we're going with respect to the y-axis, our bounds of integration are where to where? The lower bound is y equals 0, and the upper bound is 2. Why is it 2? What's the point of intersection? If we put 4 inside there, this point here is 4, 2. And we're taking with respect to the y-axis. So from the origin, which is 0, 0, from 0 to 2. So that's the first thing you have to be very conscious about. You don't take with the x anymore. You find out what the y values are. And we do the same thing. We have f of y minus g of y. So in this case, what's our farthest to the right? What function's farthest to the right? Look at our graph. The farthest to the right is this one. That's the x minus 2 graph. That's the f of y. Well, that's the f of x, I should say. We haven't changed it to y yet. So this is the outermost, and this is the innermost. Oh, this is what y. But you see, the problem is with here. The problem is with these two. We have to first label what they are. Now find f of y and g of y. You now have to find functions with respect to y. For example, this one here is y equals x minus 2. So solve for x. Solve this equation for x. X equals y plus 2. This is the function we'll use. So it's gonna be y plus 2 minus, what's this graph? That one is y equals square root of x. Solve for x, square both sides. So x equals y squared. And there we have it. You have to change, once you switch it to dy, you have to solve your equations. You have to solve your initial equations. Instead of for y, we have to solve for x. These are the functions we'll be using. Yes or no? I mean, you guys are zero face reactions. Am I losing you? Do you understand anything I'm talking about? Or have I just been talking? So no, you don't understand. You have to be honest with me. You're gonna learn, you're not gonna accomplish anything but you lie. What you have to do is not only do you have to change the bounds of integration, you also have to change the functions. You're not solving for y anymore, you're solving for x. So solve for x. When integrating with respect to y, solve both equations for x. And then find the bounds of integration with respect to the y-axis. So we changed our original one, which was example 6. It was from 0 to 2 of square root of x dx plus 2 to 4 this is with respect to the x. Oh, we're doing with respect to x. Now what we have to do with respect to the y-axis so for this one, we found where they intersect. Do we? No. So find where the two functions intersect. We got y squared is equal to y plus 2. So we have y squared minus y minus 2 equals 0. Y plus minus 2 and 1. So it goes from y equals -1 to 2. But since we're in the first quadrant, our bound of integration from 0 to 2. So we know for our area, we're going to be going from 0 to 2. And we do the graph. The farthest right function is x, or x equals y plus 2. And the inner function is x equals y squared. So it's going to be y plus 2 minus y squared. That's what we're going to be taking inside here. So 2 plus y minus y squared dy. So now we can integrate those. We get 2y plus y squared over 2 minus y cubed over 3 from 0 to 2. Two times 2, 2 squared over 2, 2 cubed over 3, minus 2 times 0, 0 squared over 2, 0 cubed over 3. All those go to 0. 4 plus 4 over 2 minus 8 over 3. So it's 4 plus 2, 6 minus 8 over 3 makes it 18 over 3 minus 8 over 3 makes it 10 over 3. You notice it's the same area as the other one. And it should be, because it's the same graph. It's the same graph. It's the same area we're looking for. Let's do one more and we'll call it a semester. We have 2 minus x squared, and we have negative x. We did this one earlier, so let's do it again. But now we're going to do it with respect to the y-axis. So let's look at the graph of this one. Negative x, that's this one. We're only in the first quadrant. We're only the first quadrant. All right, so this one here was y equals negative x. This one is y equals 2 minus x squared. The first thing we have to do with both of these equations is what? Remember, I only want this area here horizontally with respect to the y. Do I even need the second equation? This one contributes nothing because I'm only looking for the first quadrant. This one doesn't do anything. I don't even need it anymore. So the only thing I'm looking at here is this one. So I have y equals 2 minus x squared. Subtract 2 from both sides. change the signs. So we have 2 minus y equals x squared. Square root both sides. So we get x is equal to plus or minus the square root of 2 minus y. We can't use a negative because I only want quadrant 1. So this is my bound. That's my function I'm looking at. So square root of 2 minus y dy. So what are my bounds? Well, since I'm in the first quadrant, I'm going from y equals 0 to y equals 2. So my area is 2 minus y to the power 1/2. We can use substitution here. What is du? Or, yeah, what is du? -1. Again, if you guys don't see the answers, don't sit there and stare at the board. We wasted so much time just staring at the board. If you don't understand, I don't know. Then we can be honest. We move forward. I'm missing a negative in my function. This is du is -1 dy. So I got to put a negative in front, which means I got to put a negative out in front. So my function is u to the power 1/2 du. The integral of u to the power 1/2 is u to the power 3/2 over 3/2 from 0 to 2. Negative 2 3/2 times 2 over 3 minus 0 makes it negative 2 over 3 times 2 square root of 2. Take the absolute value of it, because you never have a negative area. So the area we're looking at is 4 radical 2 over 3. This is the way you can transform whether you do it horizontally or vertically. When you change it from dx to dy, you have to first take both of your equations, solve for x, and then find where the bounds of integration are. You're no longer on the x-axis. You now are with the y-axis in what you're looking for. Did any of that make sense? Because you guys are staring at the board again like nothing's happened.
Just a little bit. It's just I get a little bit confused on. It's just I want to say that yeah, sure, everything. It's just it's mostly how when you answer like how the question when on the questions when the question asking a different answer should have been can it have to be the same the question what we just did like right now, or does it have to be a different?
What do you mean the same same answer?
No, I'm saying this the No, not this, I'm saying that when they ask, like the question here, y equals two x2, what happened if it was just y negative x squared by itself? No, if they ask a different question, like if it was y equals negative x2 equal and y equals x. Yeah, just like that. What happens if they ask that question, if there was a question like that?
Well, you solve for x.
Just by,
Well, first off, it won't happen because if the first thing you have to do is change the signs, then you have to square root. And now you have an imaginary. You can't graph imaginaries. But if you were given something like this, then first thing you have to do is solve for x. Move this over there and divide by 3. This is your new is of y. That's the only variable inside there.
okay, no, that's the only question I want, that's the only question I need to know, okay?
Yeah, so integrating with respect to x, you'll have f of x minus g of x. Integrating with respect to y, you're going to have your only variables you have in your equations are y. So that's going to come x equals some function of y. And this is x1 and x2. F is some or g of some function of y.
Okay,
So whenever you do the transformation of the whether vertical or horizontal, you have to change everything. Not only do you solve for x, you also have to see where it crosses the or what bounds you're looking for.
okay,
The same way. So we'd set f of y equals to g of y, and solve for y. Those will give you the C and D. The y values will give you those.
okay, now I understand this one.
Yeah, so it just what's hard about what's difficult about this one is because it's shifting.
Okay,
Yeah, and once you get used to it, it's the same thing we did earlier. We're using substitution. All right. End of course. No more lectures. So you guys get your stuff done now. I sent out last week